Scatter plot.
Scatter plots and association. And this is part 2, which is talking about clusters and outliers. So let's listen together.
Clusters and outliers in scatter plots. A cluster is a set of closely grouped data. Data may cluster around a point or along a line. And an outlier is a data point that's further away and very different from the other points in the set. So if you saw a graph like this, you can see that these are all clustered together. So these values are very close to each other. So it could be a group of kids that are all roughly the same height, and maybe there's one tall child, or...
Did you understand this part? We are explaining what in this part here? This chart.
The outlier.
And what?
Because the outlier is have a different places and different points, not like the lister should be closed data.
Yeah, so we have a bunch of points here, or a group of points next to each other here, right? So as I said yesterday, this part, it will be, or this group of points, we can call it clusters. This group of data, yes, we can call it clusters, right? So maybe we are going to take the height for the student in the class, and we found that their heights are very close to each other, but we have one is very tall. When we represent the data like this, we found that we have a set of data very close to each other, and we have one is far from them. So this set of data, we can call it what? We can call that this group is clusters. They are close to each other. But this one represent what? Represent the outliers, okay? So this one is called what again, grade 8? This group of data is called? Clusters, and this one is called? Outlier. So let's continue.
It could be a group of children who got a certain grade on a test, and then one did exceptionally well, see? So that one out here is the outlier, and that's the cluster. Well, a real estate appraiser made a graph of the home values for one city block, and he plotted the values on a coordinate plane to examine the data to compare square footage to price for the houses. And this is what he came up with. So here's 1,000 square feet, 2,000, 3,000, 4,000. So that would be a very, very big house, wouldn't it? 4,000 square feet. Most houses are between 1,000 and 2,000 square feet. And here's the prices: 100,000, 200,000, 300,000, 400,000. Now that's in dollars. So it'd be $100,000 house, a $200,000 house. And see how I have a K here? You're going to see that a lot. Adults use the K because it's an abbreviation to represent thousand. So somebody might say, I just got a job for 50K. That means they got a job for 50,000 a year. The K stands for the thousands, see? And by looking at this, we can see that most of the houses have between 1,000 and 2,000 square feet, and they're around 100,000 to just under $200,000 for the house. And then we can look over here, and here's 304.
Is there anyone can explain to me this part? What did you understand from this part? This chart now is represent the relation between, this chart in front of us now represent the relation between grade 8
price and homes.
The price by thousand or dollar or what?
Thousands.
Thousand. And what the vertical one represent?
Size of the house.
The height. The height of the house, right? So this one is the height of the house, and this is the price of the house. Is there anyone can tell me what do you recognize from the set of data here? This is the prices, right? We started here was 100,000, right? Which means each one here represent.
It's no correlation because it doesn't have means.
I'm not talking about if it's correlation or not correlation. We are talking about what you recognize from the set of data now. The most houses in this chart, it's between
100 and
They have the
200K.
same price.
between if we look at the feet, the height, it's between what 1,000 and 2,000 feet, right? If you are talking about the height, so it's between 1,000 and 2,000 feet. If we look at the prices, so the cost or the price in this chart, it's between what?
100,000 and 200,000.
Yes, 100,000 and 200,000. And we have a cluster in this graph, right? We have clusters in this graph. If there anyone is outlier, we can find outlier in this one, in this scatter plot.
Yes.
Yes, we have. Where we can find a cluster, sorry, the outlier in this graph. Yes, Ahmed.
here.
What is the price of the outlier?
What's they?
The price.
ثانية.
مم.
بس هو between كل واحدة كام يعني قد إيه؟
Here of this one it's the 300, right? And this one is 400. So we can say 350, 325, 350, 375, and then
هي
400.
325.
Yes. So this one it will be 325 or 350.
350 قصدي.
350, right? So the price of the outlier, if we look at this point, represent what? It is 350, the price, 350,000. And what is the height for this thousand? For this house? The height is 3,000, right? So let me say something. In this one, this is the outlier, right? So I want to know what is the height for this outlier, and I want to know what is the price for this outlier, right? Because this point, it seems like it's far from the rest of the data. This point is far from the rest of the data, right? For this reason, we said that this one represent what? Represent what, grade 8? This point which I draw around, this one is represent the outliers, right? So this one
Okay.
represent the outliers. Okay, so as I said, what is the price here? The price for this house, it will be
350.
350,000. And what is the height for this house? How you will find the height?
3,000.
3,000. How you will find the height? If you will look the vertical x. How you will find the price? You will look at the horizontal x. Okay, then you will find the outlier. Let's continue.
For the house. And then we can look over here, and here's 300 and 400, so that right in the middle would be 350. This house has $350,000, and it's got 3,000 square feet. See that? So we can look at this graph and see that most of the homes are about the same size and price on this city block, except one big expensive house. So it's probably a mansion or something, right? And with this scatter plot, we can imagine what the houses might look like on that city block. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 houses that are pretty close to the same size. They vary a little bit in size. And then there's this one big, huge mansion. See? That's the outlier. That's the one that's sticking out like a sore thumb. All right? So scatter plots are they're also called scatter diagrams. And they're a graph of ordered pairs of data. The data is plotted as points and scattered around the coordinate grid. So these are just scattered on here. It's a scatter plot. See that? And this would be the X values, the price of the homes. So 100,000 and 1,000 square feet would be, the 100,000 would be the X value, and the 1,000 square feet would be the Y value. See that? Now, who uses these scatter plots? What's the big deal? Well, check out how much they make each year. An economist, what they do is they analyze what happens with prices, employment, inflation, and stuff like that in our economy. Why did the house prices go up? Why did they drop down? And they make about $100,000 to $115,000 a year in the year 2015. That's a pretty good job. An operations research analyst, they interpret large amounts of data to help the government or corporations solve problems with their businesses. And they make about $43,000 to $77,000 a year in the year 2015. A management analyst, those are management consultants, and they can either work for a company or have their own management consultant company. And they advise governments, corporations, nonprofit organizations, like churches and stuff like that, to help them boost their profits. And they can make anywhere from $45,000 a year to $150,000 a year if they're really good. And there's market research analysts. They conduct consumer surveys and focus groups, and they collect and analyze data for prices, products, and they can compare past sales to predict future ones. If last October you sold 200 widgets, then there's a very good chance you're going to sell about 200 this October, right? A haunted house had 4,000 people come through there last year. They can estimate about 4,000 might come through this year, unless they did something to increase the people coming through. And market research analysts make 34,000 to about 117,000 in the year 2015. It's like on that show, Family Feud, if you've ever seen that on TV, they always say 100 people were surveyed and they were asked this question, and then they show on the game board how many out of the 100 answered it that particular way. Well, some market research analysts had to go out and speak to those 100 people and ask them the question and collect the data. See? So that is interpreting clusters and outliers. That's scattered plots. And
okay, so did you see how many branches we can use it, or it will be the scatter plot, it will be useful to use it? How many branches? Why we have to study scatter plot? 4 branches. Is there anyone can tell me what is the type of branch we can use a scatter plot? Why it's important to study scatter plot in our real life? We said that we have 4 branches, right? The first one is
Economics.
Economics, yes. And what else? Operation, research, analyzed, management, analyzed, market research, analyzed. So it depends on the data, which we have it in the scatter plot. So you can take your decision to improve your product or to sell more or to fix a problem in a specific situation and so on. So the scatter plot, what is the important for a scatter plot in our real life? What is the important? We can use a scatter plot in our real life. We can or we can't. So in case if you have a group of data, you can take your decision according this data or not. Question number 5. Okay, Kenzie, go on.
Will be positive because is the business increasing as the year increase and this go up.
Very good, very good. So the answer for this question, it will be the data generally shows a positive linear association as the years increase. So does the winning distance, right? So the both two data are increasing, the years and the distance. Thank you, Kenzie. Let's move to the next question. Who is going to answer question number 6? Describe the association between the year and the distance jumped from the years after 1988.
Miss, may I answer?
Yes, sure. Go on.
Do I read the question first?
Yes, please.
Okay, describe the association between the year and the distance jumped for the years after 1988.
From 1988, yes.
It will be negative.
It will be negative, yes. Look at after 1988 in the graph, you will note that the points start to move down, right? So once the points start to move down, as you said, Johanna, so we have a negative association, right? So the answer for question number 6, could you please write with me? Overall, the data from 1988 to 2012 generally show a negative association, even though the 8 years period from 1996 to 2004 looked at by itself shows a slight rise in distance jumped over time. Let's move to the next question. For the entire scatter plot, is the association between the year and the distance jumped linear or non-linear? Look at the data here. It's linear or non-linear when we look at the graph here.
Non-linear.
Yes, go on.
It's not linear.
Yes, it's not linear.
No, I'm used.
Talking. Yes, it's not linear. Yes, yeah. Why?
Because there is a part positive and another part negative.
Very good. Because at the beginning, we noticed that it was positive, it's increasing, and after that, it becomes to go down, decreasing. So we can say that it's non-linear. The data points first rise as the year increase from 1960 to 1988, and then fall as the years increase from 1988 to 2012. So there is no overall linear pattern. So we can't find a linear pattern in this relationship. Question number 8. Identify the outlier and interpret its meaning. Is there any outlier in this question? Do you note that we have any outlier in this question? Yes. Where you can find it?
In 1968.
Yes, 1968.
8.9.
It's how many?
8.9.
8.9. Yes, very good. So we have outlier in this question, which is 1968 and 8.9. So, Fadia, could you please repeat question number 8? Fadia? Ali?
No, sir, I don't think Fadia is in the meeting.
She left. Okay. Ali? Ali, we are in which question,
Yes.
Ali? We are in which question?
Question 8.
Question number 8, right. Is there any outlier in this question?
Yes.
Yes.
1968.
Very good. And give me the answer as an order pair form. From the order pair, it will be 1968 and 8.9.
And 8.9.
8.9. Okay. And the outlier represents a jump of 8.9 meters in 1968, a jump that far exceeds any jump made in proper or later years. Last question. Who will answer the last question?
Miss, can I answer?
Yes, okay, go on, Judy. Compare.
Number 9.
Yes,
right?
number 9. Yes.
Compare scatter plot that shows no association to one that shows negative association.
Yes.
When the data is negative, it will show that the plots are decreasing. And when the data has like no association,
He
It's
wants to
scattered
compare.
together.
He wants to compare, right? A scatter plot that shows no association to one that shows negative association. What do you notice when you have two set of data and you want to make a comparison between them? Why you will take your decision that this one it will be no association or it's a negative association?
Me برضو?
Okay, go on.
Because the negative shows that the plots are decreasing, going down, and the no association data shows that
We can't notice
like they have no relation.
any pattern in the data, right? يعني في no association, randomly scattered data points, just points. There is no specific pattern between them. Okay, then if we want to talk about or to describe that no association, a plot with no association has randomly scattered data points. There does not appear to be any pattern in the association. On a plot with negative association, the data points fall from left to right as one data set increase and the other decrease. Okay, then when we want to talk about positive correlation, so we said positive correlation in both the two data increasing together or decreasing together. In negative correlation, one data increase, second data decrease. No correlation, we don't have any pattern between the both two types of data. Okay, so this was our lesson today, is about a scatter